For our review on exponential equations, what we're going to do first is look at here in a game show, players play multiple rounds. Each round has 3 times as many points as the previous round. So if you look here, to start, we have 25 points. And then what happens, and it says 3 times as many points, that should say 2, so make that correction. The number of points doubles. So here, our initial value is 25. And remember, in the equation, y equals a times b to the x, an exponential equation. Our starting value, or initial value, goes in the spot for a. And then b is our growth or decay factor, or what we're multiplying by. So in this situation, to get from 25 to 50, you can just take, 50 divided by 25 means that our b value is 2. And I could have done that here as well. I could have gone 200 divided by 100 is 2. So now plugging this into our equation, we would have y equals 25 times 2 to the x. And then in our situation, instead of y, they use p to stand for the number of points, is 25 times 2, and then to the n, where n is the number of rounds. So we have d. Then on here, the equations represent the number of bacteria in 4 dishes. Which equation has the highest growth factor? Well, here, so far, 4.5 is the biggest. If I take 1 divided by 50 and turn it into a decimal, I can check that in a calculator. Let me just clear that out for you. So 1 divided by 50 gives us 0.02. So far, B is not correct. We'll change 5 over 2 into decimal. So 5 divided by 2 is 2.5. So 4.5 is larger. So that's a no. And then here, 3 is bigger than 4.5. So our answer selection would be A. So now here, a new computer increases 3 times of its value each year. Which graph could represent that relationship? Well, if I'm increasing by 3 times, first of all, we can rule out 1 and 3. Those are decreases. And then as I look at this, these 2 and 4, which are increasing, this is a linear increase. And that would be adding 3 adding 3 every year. Here, if I'm increasing 3 times its value, that would be exponential. So it'd be 4 because of the 3 times. So number 4, a new music service collection has 4,500 songs. So our starting value, A, is going to be 4,500. It expects to double the number of songs each year. So B is 2 because it's doubling. So write an equation where X is the time and Y is the number of songs available. So that would be Y equals 4,500. And then I'm going to put times 2. And then you can put the X on the inside of the parentheses or on the outside. It doesn't really matter as long as the exponent goes with the growth factor. So now here, Jada saw a music video that her favorite artist posted online. The equation V of t is 480 times 3 to the t, represents the number of views it got in t days. So V of -2 means t equals -2. And if we plug that in, that would be 480 times 3 to the -2. So to put that in a calculator, you just put in 480 times 3 to the negative 2. And that would be 53.3 repeating. So I'm just going to put 53.33. And what does V of negative 2 represent? So remember, that is going to be 2 days before Jada saw it. It only had 53 views. So T equals negative 2 is 2 days before she saw the video. So now on here, for each equation, we have to complete the table. So for the first one, I'm going to go 4 times 3 and then plug into the negative 3. So we go 4 times 3 to the negative 3. And that gives us 0.15 about. This is approximating. So 4 times 3 to the negative 2 is going to be about 0.44. Again, I'm just rounding to 2 decimals. So then 4 times 3 to the 0, it's about 4. Then 4 times 3 to the first is 12. And 4 times 3 squared is about 36. And 4 times 3 to the third is about 108. So to fill these in, it's about 0.15, 0.44, I forgot to the negative 1, so this is 4. So right here, I need 4 times 3 to the negative 1. And then that's about 1.33. And then 4 times 3 to the first power is 12. 4 times 3 to the second is 36. 4 times 3 to the third is 108. So then you can graph those. So for the negative 3, it's at 0.15. For negative 2 as an input, you're at 0.44. 0, you're at 4. Oh, sorry, I forgot my negative 1. So for negative 1, I'm at 1.33. It's a bad one. And here at 0, you're at 4. At 1, you're at 12. At 2, you're at 36. And at 3, you're all the way up at 108. Or kind of off the graph. So you see you have the exponential curve. And then lastly, the number of milligrams of aspirin in someone's body is given by the equation 100 times 3/4 of the t, where t is the number of hours. So how much is aspirin is in the patient's body after 2 hours? So you'd go 100 times 3 over 4 to the second power for 2 hours. So you can put that in a calculator like this, 100 times, and then here you can just put 3 divided by 4 and then raise that up to the second power. And that's going to give you 56.25. And here, this should not be 1,000, that's 100. So what does 100 tell us? You had 100 milligrams to start. And the 3/4 tells us that you keep 3/4 of the aspirin in your body each hour. Or you could also say that means you lose 25% or 1/4 of the aspirin each hour. So to now graph this at time 0, so I'm going to put time, and then here it's just going to be the aspirin. We're at time 0. So I'm going to go 100 and then put parentheses times 3 divided by 4. Close the parentheses to the 0. That gives us 100. Then what you can do is hit 100 and then times 3 divided by 4, and then raise it up to the first power, and you get 75. And I'm going to graph these points as well. At 0, I'm at 100. So 0, you're at 100. At 1, you're at 75. And then at 2, so 100 times 3 divided by 4. So the 2 is 56.25. So 2, you're at 56.25. And then 3, 100 times 3 divided by 4. The 3 is 42.19. And then we can go to 4 hours. So a trick there, you can hit second entry. Then to the fourth is 31.64. And you get a small growth decay curve.